So, a few years ago I decided I was going to learn Clojure. The main problem I had with it was actually the Lisp syntax. Having learned the Lisp syntax, I think is really cool, and I would like to share with you why that is. So let's look at some code. Now, this is the sum function in basically any C-inspired language, right? So let's clean this up a little bit. Wow. So now we're not talking Java or C# anymore, but a lot of other languages. What else could we do? Well, if you move the paren before the sum function, look at that. Wow. That's crazy, right? Well, this is Lisp. This is called prefix notation. This is the only way that you can actually call code in Lisp. So you have a start paren, a function name, and then parameters. That's it. In other languages, like say for instance Java, there are so many different ways that you can actually call running functions. In Lisp, it's only this way, so I'd actually argue that this is a lot simpler. So let's look a little bit more at the sum function. So it's a variable argument function. You can take 0 many arguments, and it basically does what you'd expect. I think most people are quite alright with this. What the sum function really is, it's just an alias for plus. Now, when people see this, they usually don't like it at all, because we're used to seeing mathematical operators in infix notation. We're used to seeing 1 plus 2. But in Lisp, plus is just another function. It must be placed in infix notation. There's no special rules with mathematical operators, they're just functions. So again, I would actually say that this is simple. There are no special rules with operators as they are in different or other languages that has infix notation. Now, using parentheses, that's actually literals for lists. So lists are extremely central in Lisp, and you use them both to represent data and code. Using lists to represent code, you often get a lot of nesting of lists. So looking, for instance, at a really powerful function in Clojure core called iterate. Now, this is an amazing piece of software, really, but what people react to is really closing parentheses, right? Well, there's a really good reason for representing code and data the same way, and that is called macros. So this expression obviously wouldn't work because 1 is not a function, so that would fail. But if we wrap this inside of the infix macro, it would actually work. So how does this macro, what does this look like? So this macro, it takes a form or an expression as its parameter, then it calls, it returns the list, and it calls the second function here, and it picks out 2, and then it picks out 1, and then 2. So if you expand that expression, what you get is a perfectly normal prefix notation expression. So this would work fine. Now this is compile time metaprogramming. There's no runtime overhead for doing this. The functions that we're using here, second, first, and n next, these are just regular functions in Clojure core. There's nothing special about them. You use them normally to program against data. But in this case, we're actually using them to program against code. So that's really what makes Lisp really powerful. Metaprogramming becomes a really integrated part of your program. It feels really natural. So let's go back to the iterate example. Now what you have here is actually lists inside a list, inside a list, inside a list, inside a list. So what you're really programming here is a tree. And that's not just any tree. That's Lisp's abstract syntax tree. So if you have other languages, they have a syntax, and then the compiler takes that syntax and it turns it into the abstract syntax tree, and then it does stuff with it. In Lisp, you're already programming in the abstract syntax tree. So you might even argue that Lisp doesn't even have a syntax. Now, 5 minutes is not enough time to really show you the power of Lisp, and that wasn't really my intention here either. What I really would like you to do is learn Clojure, which in itself is a truly amazing language, and please don't let the Lisp syntax stop you. Thank you.